Hi, in this episode we will look at interfaces. What is interfaces? What is it good for us? This is actually resolving or solving abstraction. What is abstraction? We are abstracting out the business logic from the actual implementation. So we hide the concrete implementation and we will focus on the business requirements instead. This is very good. This way we can replace implementation without changing the code anywhere else. We will use it for creating cleaner code, much easier to expand our code later, much easier to test later, and we will see those when we move to the testing part. For example, if we have a data which is coming from a database, and later we will update our system, we will change the system, and the data will come from an API. If we use abstraction, then we can replace, and we don't have to touch the code anywhere else, only the concrete implementation, and just use the same abstraction level. But it's easier to understand if we continue the example what we started last time, and we'll see how it works in reality. Let's open our code and just review what we have done before. What we have done before, we created a so-called object, in quotes object, which is a bank account. And the bank account we can initiate with the initial balance. We can get the balance. I will remove the change balance here because we will not use that in this example. And we can deposit some money into the balance, and we can withdraw some money from the balance. What we're going to change now, we will have two different kind of accounts. We have saving account and we have current account. In the saving account, when I get the balance, we have some interest what we are receiving, and in the current account we have some costs including this account. The two implementation is almost the same. The only difference will be the interest or the cost. So we can use the same interface, the same contract to achieve both goals. So for example, I just visit my website, online banking website, and I click on my bank account. It can be a saving account or it can be like a current account, and I click on the balance and I will see my balance with the interest or with the cost. But in our case, it doesn't really matter for the system what type of account do I have if I use the correct implementation. Let's say it in practice. First, I'm just going to rename this, and it will be a saving account. And I keep it as it is, except that I'm adding a new function. As you see, I start with small caps because I don't want to export this. And just for the simplicity, let's say the interest is like £10, $10 or whatever you think. And let's change the get balance where we say return a balance plus interest. And if I go back to my main, I have to change the import to saving account. Let's rename the package saving account. And if I run, hopefully it still will work. Yes, it still works. Okay, then let's create another account. So just going to copy this folder as it is and rename it to current account. Rename the account to current account. And instead of interest, let's say cost, and the cost is 10. So it will be a minus and r dot cost. Just a simplicity. Obviously, in a real banking system, this is not how we calculate costs and interest. Yeah, so I have two different implementation, but as you can see, they follow the same principle. And if I want to make sure that they are interchangeable, then I can do the following. I can create so-called contracts or interfaces. I will create a new folder for this as well. I will call it contract. And I will call the file contracts go. Will be go into package contracts. Now we create something called interface. Same way, type contracts. Bank account. But now I will say interface, not struct. And what I have to do within the interface, I have to define the contract properties. So what happens here, I'm just going to define what the object must know, must follow. And what must the object follow? Let's see. It should have a balance, which returns an integer. So just copy this. Maybe it's easier if I split the screen and go back to the contracts. Where's the contracts? Yeah. So that needs a balance. That needs a deposit. And that needs the withdrawal. I can do it only for exported fields. For not exported fields, this is an internal logic. I will not export this. So contract is just like a real life contract. When I signing a contract with someone, and I'm saying that this they have to adhere to this contract. This is the same. This implementation must adhere to this contract. But let's see how we can use the contracts here. Let's go back to our accounts. I have the contracts ready. And here I have the current account. And let's replace this with contracts. Bank account. And if I'm using contracts, I always have to return with a pointer. Let's do the same for the saving account. And instead of the actual struct, let's return contract, the interface, contracts, bank account, and return it as a struct. Let's run this. And if I run this, it still works. It does the same. So let's do some modification in the main and see how we can use these two different things. And let's see. Say I create a function, func display balance, and this display balance will now take a contract, which will be account, and contracts bank account. It's even better if I call it bank account, because I don't want to shadow any package names. And whatever I have here, I just move it down there. And I will use bank account balance, bank account deposit, bank account balance, bank account withdraw, and bank account balance. And instead of the account new, that's a saving account, let's call it saving account, as it says here. I don't need the alias anymore. And shorten it down as account, and call display balance with saving account. Let's see what happens. Same, so I just restructured the code. I didn't do anything else. But now let's do something else and create another account, which will be a current account, and call it current account. It's automatically imported for me. and display the current account as well. It's not only displaying, so the name is not really good. Update and display. I will rename it just in case it reflects what it does. And if I run again, let's see the results. In the first one, I have the interest. In the second one, I have the cost. And what I did, I used the same interface, and I declared the interface as a function parameter. This is what we call dependency injection. We insert a dependency here in the function, and we will just use it knowing that this kind of contract must have a balance, must have a deposit, and must have a withdraw. And this is how we can implement a code which is easier to test. We will cover it later. Easier to expand with new features, and more cleaner to read as well. But we still not ready with covering everything. How can we simulate object-oriented principles? Because if you know another languages, you know that we have something called inheritance, and Golang doesn't have that inheritance, but we have something else as well. And instead of inheritance, Golang prefers composition. And this is what we're going to see in the next lesson. If you don't want to skip this lesson and make sure that you get a notification, then don't forget to subscribe to the channel or click the bell icon as well. See you in the next episode.